Hello, my name is Cristian Wulkop, and today I'm going to talk about how genetic engineering works. You might have not heard about genetic engineering before, or you might have simply not put much thought into it. However, genetic engineering has the potential to do things such as eradicating different diseases like cancer and HIV, creating the so-called designer babies, and even curing aging. In this presentation, I'm going to talk about the basics of genetic engineering, some applications that genetic engineering has, and I'm going to talk about a recent breakthrough that might change our future substantially. Humans have been doing genetic engineering for thousands of years now. By selectively breeding, humans can strengthen different useful traits in plants or animals. An example of this is the wild banana. Bananas used to have thick skin and big seeds. However, the bananas that we eat nowadays are super easy to peel and are also really sweet. Scientists never really understood how the changes in different species happened until we discovered DNA. DNA is a complex molecule that basically guides the growth, development, and reproduction of every single thing that's alive. DNA stores its information in its nucleotides, which are basically the structural units of DNA. There are only 4 different nucleotides that pair with each other and make up a code that makes up instructions. The idea behind genetic engineering is that if you can change the instructions, you can also change the living being carrying them. Now that we've covered the basics of genetic engineering, we can now look into the different applications that it has. At first, scientists started exposing plants to high amounts of radiation, hoping for genetic mutations. Ideally, these genetic mutations would cause some of the plants to be useful plant variables, but this rarely happened. Later, scientists began to inject DNA fragments into animals, bacteria, and plants for research, medicine, and agriculture. This led to the birth of the first genetically engineered animal, that was a mouse, in 1974. Thanks to genetic engineering, now we have things such as insulin, life-saving blood clotting medicines, and growth hormones that we previously needed to harvest from animal organs. We also have things such as genetically modified food. An example of this is the flavor saver tomato, which basically has an extra gene that inhibits one enzyme that causes rotting in tomatoes, therefore giving it a longer shelf life. These are all great uses of genetic engineering. However, until recently, genetic engineering was highly expensive, highly complicated, and it also took a long time to do. A recent breakthrough called CRISPR helped the prices and complexity and also time of genetic engineering to decrease dramatically. CRISPR is sort of like a DNA archive that is found in bacteria. When a bacteria is attacked by a virus and the bacteria survives, the DNA from the virus is stored in this archive called CRISPR. If the virus attacks again, the bacteria can synthesize a protein called Cas9 from the previously stored DNA. Cas9 cuts down the virus's DNA, preventing the bacteria from harm. Cas9 works sort of like a DNA surgeon, and it's also highly programmable, meaning that you could give Cas9 a sample of DNA that you wanted to modify, and it will do that for you. Later, you could put that modified DNA into a living cell. This has the potential to cure basically every single disease. Now that we've talked about the basics of genetic engineering, some of the applications, and also a recent discovery called CRISPR, I hope that my presentation gave you a lot to think about, because it's giving scientists and ethicists a lot to think about. CRISPR has the potential to change the future. It can do great things for humanity, such as eradicating lethal diseases, but it also can do things that are considered to be ethically wrong, such as genetically modifying your own baby. I want you guys to think about the different possibilities or repercussions that CRISPR might cause in the future, because we might need to redefine what is right and what is wrong. Thank you for your attention.